Hello and welcome. Today is 1st December 2020 and we are exploring real numbers. Specifically today, our focus is to find out how to solve this particular exam question that comes from this chapter very often in the final exams. So, how do we find HCF? In this video, we are going to find HCF using Euclid's division lemma. So let's take a look at the question we are talking about and how do we go ahead and solve a question like this. So here we go. If HCF of two given numbers, then our given numbers in this example, they are 156 and 240. If the HCF of these two numbers is written in a form of, in this example, this expression is given 5n minus 13. So then what is the value of this expression 2n plus 3? These type of questions typically carry 3 marks. So let's find out how we are going to go ahead and solve a question like this. Now, these type of questions are solved typically in 2 steps. First, we have to find out the HCF. The numbers are given using either Euclid's division lemma or prime factorization method. We need to find out the HCF. That is the first step. Once we find out the HCF, then whatever the number is, that will be equal to this. In other words, say our HCF is x. Then 5n, which is this expression given, minus 13 will be equal to x. And from there, we are going to be able to find out the value of n. Once we know the value of n, we can simply plug in over here and be easily able to find out 2n plus 3. This is how we solve these questions. Let's quickly go ahead and solve this particular question. So like we said, we can use either prime factorization method or Euclid's division lemma. For purposes of this video, we are going to find out the HCF of these two numbers using Euclid's division lemma. So we know that Euclid's division lemma states that we have to divide the larger number by the smaller number. So let's go ahead and apply Euclid's division lemma. So we write 240 over here and now we have to do the long division. So we divide 240 by 156. So 156 ones are 156 and here we subtract this out. So here this will be 4, this will be 8. Now this is our new divisor and our new dividend is now 156. We write 156 over here and now we divide 156 by 84. So this will again, if we do 2, it will be 2, it's a 16, it will become more than this. So 1 and here we have 84. When we do this subtraction, we will get 2 and here we will get 72. This is a new divisor. We divide this by our dividend now is 84. And now when we do this division, again, this will be 1. Here we have 72. And this will be 2 and here is 1. 12 is a new divisor. At this point, the dividend is 72. 12, 6 are 72. And finally, our remainder has become 0. Division process stops and the divisor at this point, which is 12, is our HCF. So we know that our HCF is 12 using Euclid's division lemma. So now let's clear this up. So we have 5n, which is the expression given, minus 13. This is equal to 12. So from here, we will get the 13 on the other side. So we will have 5n equals 12 plus 13, which will be simply 25. We divide both sides by 5. So we simply get n is equal to 5. Right? N is equal to 5. Now we know the value of n. Simply plugging in over here, we can say then 2n plus 3 is equal to 2 times 5 plus 3, or simply 10 plus 3, which is nothing but the number 13. This is how we solve such problems.